I'm going to show you how to use the make noise maths and the Modcan Quad LFO together to synthesize a signal that tracks the pitch and envelope of an input signal without using a voltproactive pitch signal. The initial patch I have set up here, which is what we're going to track, is a Dixie VCO into VCA here. Channel 1 of the Quad LFO is triggering an envelope on the quadra, which is going into the VCA also. So it's just going to be a pinging sound. Let's see, what does it sound like? There it is. Okay, and you can see that on the oscilloscope also. Okay, so the first step is we want to track the pitch using channel 1 of the maths. We're going to be using channels 1 and 4, so we'll put this mult into both of them, and we'll take the output from the VCA into both channels. Channel 1 is going to track the pitch. We have rise and fall set to the full counterclockwise, and the log X knob set right to linear. Now, right now, before we do anything, what are we getting on this signal output of channel 1? Let's look at it on channel 2 of the oscilloscope. Basically the same as the input signal, which is what you'd expect. It's tracking it directly. Now, if we look at the end of rise signal from channel 1, we're getting a pulse train that tracks the frequency of the input signal. So there's a pulse for every positive going pulse of the input signal. So this is tracking the frequency. Now we're going to use a feature of the Quad LFO, which is that it can track or follow an input pulse train in its tap tempo mode. So we're going to look at LFO2. We're going to set it to yellow, which is the sync tap mode, and we're going to connect the end of rise signal to gate 2. That's going to make LFO2 track the frequency of our test signal. Let's see what it looks like on the channel 2 of the oscilloscope. So here it is. It's a signal that tracks the frequency of the input signal. If we adjust the Dixie's output, we see that the Quad LFO's frequency adjusts correspondingly. Right? Okay, good. So now let's track the envelope. So we're going to use channel 4 of the maths to track the envelope of our Dixie signal. Okay, so if we set the rise and fall fast the way we had them on the other channel and the log X to linear, what are we getting on the output signal here? Again, it's the same as the input. If we start to slow down the fall by turning it clockwise, the maths output starts to track the envelope of the input signal. That looks pretty good right there. So now we have the maths tracking the envelope and the pitch of the input signal. So let's take this envelope output into another channel of our VCA. Sorry about that. It's going to be the control voltage. LFO2's output is going to be the input signal. So what is LFO2's output, or what is the output of the channel 2 of the VCA then? So it's a signal that tracks the frequency and the amplitude of our input signal. Now, because this is the Quad LFO, it's got a billion options. We can change the waveform to a sawtooth with some shape parameters. We can change it to a reverse sawtooth, or different. There's all kinds of different options with the Quad LFO. We can change the frequency. If we reduce this to 2, it divides the frequency by 2. That's an octave lower, like a sub-oscillator. And now it still tracks the frequency quite well. So now we're getting a 2-octave down sub-oscillator. Okay, guess we're done. Thank you very much.